Writing a rule to describe a dilation. So in the last video about dilations, we actually went over the rule for dilation on how to describe it. In this one, they actually want us to go through and write it out. So a dilation centered at the origin with a scale factor of 1/3 is applied to triangle XYZ. And the result is XYZ prime. Each one of these little apostrophes is actually, we call them prime. So it's as shown below. So we start with this larger triangle, and then we have this small triangle inside of them. So the arrows below show that the coordinates on the left are mapped to the coordinates on the right. Fill in the blanks to give the coordinates after the dilation. So then we go through and we would find the points of X, Y, Z prime, so the new ones, and then we have to make a decision. What is the rule? How did we get from here to here? What do we do? And if you don't know what a dilation is, it's one of the 4 transformations. We have translate, we have rotate, reflection, and dilation. So dilation is the new one this week, and it's all about taking a figure and either making it bigger or smaller. So if we're multiplying by 1/3, or we have a scale factor of 1/3, then that means we're making it smaller. So it's 1/3 the size. If we're multiplying by a number larger than 1, then we're making it bigger by that number. So it's a fun relationship there to remember. So I'm going to scroll down here because this is the explanation. So here are the 3 coordinates. They went through and found the 3 coordinates for X, Y, Z. And then we can look at the relationship here. So we have -9 and 12, and that goes to -3 and 4. So if I look at 9 and 12, can I divide by something to get down to 3 and 4? Sure I can. I can divide by 3. -9 divided by 3 is -3. 12 divided by 3 is 4. Well, why am I dividing by 3? Because I have a scale factor of 1/3. A fraction is simply division. So you multiply by the top, you divide by the bottom. So if I have a scale factor of 1/3, it means I divide by 3. And that is literally the rule. You either multiply by the number it gives you if it's bigger than 1, or you divide by the fraction if they give you a fraction. And then we just go down here and we choose the one that shows that we multiply by a fraction on both X and Y, and it always goes X then Y. For the other ones, when we were doing some of the other transformations, the X and Y flip-flopped. Well, dilation doesn't flip-flop. It stays X and Y. We just have to make sure we multiply by whatever scale factor they give us, and in this case, it was a 1/3. All right, so let's go ahead and start. Okay, so this is a dilation centered at the origin with a scale factor of 2/3, and it's applied to triangle RST, which results in RST prime down here below. So, and I'm just saying the prime once, so I don't feel like saying it 3 times there. So the arrows below show the coordinates on the left are mapped to the coordinates on the right. We need to fill them in, so we need to get our 3 coordinates. So we have R prime. If we start here at the center, we have to go, let's see, we have to go left 2, which is a -2, and then we have to go up to 6. So we have -2, +6. S, we have positive, oh, nope, sorry, I need to go to prime, +2, so we're going to go right 2, and we're going to go up to 4. 2, 4. And then we have T prime, so we want to come here, so we want to go left to 6 and down 2. So left 6, down 2, those are both negative. Left and down are our negatives. Right and up are our positives. Okay, so we have our points here, but how did I get those points? So this one's not as easy to just recognize, so I'm going to turn my pen tool on here so I can kind of write on the screen. So we talked about this in the last page. All we do is we multiply by this number here. So remember, the top is multiplication, the bottom is division. So if I take -3, so I'm looking at this first point, and I multiply by 2 and divide by 3, I get -6 divided by 3 equals -2. Oh, look at that. I landed on -2. And I can do the same thing with the next one. So I have 9 times 2/3. I'm going to multiply and then divide. So 18 divided by 3 is 6. So we still have the exact same rule, -2, 6. So remember, whatever the scale factor is, we're going to multiply both x and y. So the first and second parts of the coordinate. So now down here, we just need to choose the one that shows x then y and 2/3 for each. So here's x then y and 2/3 for each. So just make sure it is in the correct order. And like this one down here is not correct because one says 2/3, one says 3/2. So we don't want that one. This one says 3/2 and 3/2. We want to make sure it says 2/3. So I'm making sure I choose the one that has both 2/3 being multiplied by x and y. All right, check it. And we're good. All right, I'm going to clear out what I wrote there, and we're going to go next. All right, so a dilation centered at the origin with a scale factor of 3 is applied to triangle RST. So we can see this here. So RST is actually the small one. Prime for triangle RST is the large one. So we should know right away if we have a scale factor of 3, it's bigger than 1, which means we're going to take a small triangle, we're going to make it larger. If we had a scale factor of a fraction, that's when it gets smaller. So this scale factor right away should let you know if you're going to get bigger or smaller, okay? So if we know the rule already, because we already practiced it, we can go ahead and test it real quick and see if it works. So if I know I'm just multiplying by the scale factor, let's go ahead and do that and then see if it works out. So we have 2 times 3, we get 6. 3 times 3, we get 9. And I'm multiplying by 3 again because of the scale factor. So 3 times 3, we get 9. -1 times 3, I get -3. -4 times 3, I get -12. And then -2 times 3, I get -6. So now I want to make sure that these are in fact the coordinates, just so that we know for sure this rule works. So we're going to go to r prime here. So we're going to go right 6, and we're going to go up 9. Look at that. That's exactly what we said. Up 6, right 9. Now we're going to go to s prime over here. So we're going to go right 9, down 3. Oop, look at that. It matched up again. Right 9, down 3. And then we're going to go to t prime all the way off to the left here. So we're going to go left 12, down 6. Look at that. It did, in fact, work out the correct way there. So that is the rule. We just tested it. So we tested it before even knowing the coordinates. We just multiplied, and that is the coordinates. Now, should you check to make sure? Yes, because that makes sure that you did your multiplication correctly. All right, so you can multiply to fill this in, but then make sure you check the actual graph here so that you can, or coordinates, sorry, so that you can make sure that you get the correct answer here. All right, so we know we want to multiply by 3 for both x and y. This is backwards. We don't want that one. So this one, it shows 3, 3, x, y. So this is the one that I want. Check. All right, one more. Okay, so we're going to do a dilation center of the origin with a scale factor of 1/2. Remember, this means it's getting smaller. It's a fraction. All this means is we're dividing by 2. Instead of multiplying by 1/2, it's easier to think of it as divide by 2. All right, so I'm going to come right over here, and I'm going to start dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. Go to the next one. 10 divided by 2 is 5. -8 divided by 2 is -4. Again, -8 divided by 2 is another -4. And then -10 divided by 2 is -5. All right, so let's go confirm this. So let's go with r prime first. So I'm going to write 4 up 2. There we go. I land right on it. And then I'm going to go right 5 down -4. Perfect. I land right where I wanted to land. And then the last one, I'm going to go left 4 down 5. Perfect. I have, in fact, done what I wanted to do. They all do land on those coordinates. So I know I'm dividing by 1/2. Now, when I write the rule, it shows dividing by 2. But when we write the rule, it's showing that we're multiplying by 1/2, the fraction. So we want a 1/2 in front of both x and y. Oop, I see it right here. So 1/2 x, 1/2 y. And I want to be careful. I don't want it to be flipped. I don't want it to be 2 times each one. That would make the figure bigger, and it got smaller. So I want to make sure that it's 1/2 with both x and y. And they're in the right order. So like this one has a 1/2 and a 1/2, but I see y then x. We want x then y because that's the correct way to write the coordinates. All right. Yay! We're good to go on that one.